And we're looking at number 8, 129. A 100-gram sample of radioactive isotope is taken from a protective container. After 4 hours, the sample decays to 85 grams. What is the half-life of the substance? So the question is, how long until there's half of the substance left? If it's 4 hours to get to 85 grams, we've got to know that our number is going to be higher than 4 hours. So we have a couple of things to solve for here. The first thing we're going to solve for is our rate. So the old A equals P e to the RT is our natural growth rate. So if the amount I want was 85, or the amount I ended up with, and my initial amount was 100, e to the r, and I have 4 hours, so t is in hours this time, not days or years or whatever. We can go ahead and solve this guy. Divide by the 100, 0.85 equals e to the r times 4. Now take our log of both sides, log base e of 0.85 equals 4r, and then we can divide by our 4. And I would type into my calculator natural log of 0.85 divided by 4. And I get that long decimal negative. It makes sense that our rate is negative. We are going down. 0.0406297. Now I would press my store button to use that again. So I always store it as like alpha A. So then I can reuse it later without having to estimate. And then we want to go and solve our problem for T for 50%. So we can put in 50 here equals 100 E. Now I'm going to write A because I stored my rate as A and I don't like rewriting that long number. A times a time, but I'm realizing that A represents a number I already know. Every time we divide over the 100, we're going to get 0.5. So if you wanted to skip right to the 0.5 for half-life, that should make sense. E to the A t. So now we're going to solve very similar to the way we solved over here. The natural log of 0.5 divided by the number A we found there is going to be equal to our time. Good. If we press the buttons correctly, we should get T equals 17.060 hours in this case.